So let's start the presentation of the assessment. The first point to consider, this is my student ID. So the aim of the project is building a server room door system, a server room system that takes into consideration the access provided to this room is a furthest pin, and we must check if the spin is right or wrong, and if it's right, the door remains open for a minute. If it's wrong, the person has to wait 1 minute until the door is open again. And we must, for a good operation of the room, as it's known, temperature, the voltage supplied must be taken into consideration when the system is developed. And these are the points that we're going to focus on our project. So this is a flow chart. We cannot see here very well, but this is connected to the display temperature as well. So the program starts in main function, and the first check if the pin has been set up. If setup occurs, and if yes, just wait for someone insert the pin. While someone waits, this line represents simultaneous events. So while there's the wait of someone to insert the pin, the voltage supply to the room is checked, and if there are any fluctuations or cutoffs, then the backup voltage system becomes on, and if not, goes off. And meanwhile, every 5 seconds, the room temperature is acquired, and after 5 samples, 25 seconds, the average temperature is calculated, and if the average is over 20, then the conditional temperature system is on. If not, it's off. The mean temperature is displayed, and everything restarts over again. And even when someone inserts the pin, I don't know if I made it clear, but even when this is simultaneous, So even if someone inserts a pin, so if the pin is right, then the door is open, and there is 1 minute that it remains open for 1 minute, and then the door closes, and the system goes back to this point where it waits and keeps on checking. And while someone is inside, or while if the right pin is incorrect, if the correct pin is not, the pin inserted is not correct, door remains locked, so you have to wait 1 minute until the next attempt, and the program again goes back to this point. But at any time that this is supposed to be simultaneous events, at every time, it doesn't matter the condition of the door, if it's on the 1 minute wait until the next attempt, or the door is open, or if door is closed because no one has heard anything. All these checkings must happen. So this is the function, the main function of the program. In the main function, we configure the ADC with the reference voltage set as external, because the thermometer used has steps of 0.1. So for these steps to be taken into consideration in the ADC, the resolution must increase, and with that, for the increase of the resolution, we need to change the external voltage for 1 volt. So USART is also configured here. There are further details on configuration in the project, in the report. So this is the main function. It checks if there was a setup. The setup occurs when if there is a setup, it means that the last position is the number of users, and no longer the room is no longer empty there, so the program starts from that point. that was mentioned in the flowchart. The timer is initialized for the count of 2.5 seconds twice, because when there's the overflow of timer 0 in this configuration that I said, it counts more than 2.5 seconds, but less than 5. So to make it easier, it was set as 2.5. And the timer starts, and there's a constant check and of voltage and the constant weight for the insert of pin. So these are the functions, and the number of users requested until you enter a valid number. It keeps on showing your message. As soon as you write the number of pins will be asked according to number of users. So if you put 2 users, 2 pins will be requested, and everything is going to be saved in EEPROM. Through these nested loops here, they put the pins, in sequential four sequential positions. So first position goes from 0 to 3, the second pin goes to position 4 to 7, and so on. So it checks that it's correct. So when you insert a pin, it searches every one of these 4 positions, and for each similarity of the digit per digit, checks the similarity in the same order. So if it matches, it will increase a variable, and this variable, the final value of this variable, will notify us if there is something, if the pin is right or not. If it's right, the door remains open for 1 minute. Here, this is the routine. So whenever, to count these minutes, the timer here is open, and it starts to count. So it's necessary 572 overflows, so to reach 1 minute, and then the flag is clean and the timer is off. Thermal control. The thermal control occurs every 5 seconds. It checks if there were 2 overflows. If not, first another count. If it happens already 2 overflows, acquires temperature, and if the number of overflows, number of temperatures acquired is the same, it's twice the, the number of overflow is half of the temperatures acquired. So if the number of temperatures acquired is 5, it means that it occurred. So do the arrangements, and to display the temperature, it checks. If it's over the 20, then turns on the temperature conditioning system. The voltage control occurs. The voltage is constantly checked. It's polling, different from interrupts. It's a constant check, and it's part of the main program. So voltage is acquired, and for the first time, control is initialized at 1. So the difference of voltage will be compared to the initial one. So at first, control is 1. Then when we turn on the program for the first time, so voltage stores the initial supply and starts being compared. If there is a large cutoff, which means that there's a large fluctuation, that means that some cutoff is happening, or even low voltage, then the backup system is on and remains on until the situation is reverted. So this is the simulation. So this is the temperature sensor, the potentiometer that show the voltage of the system, that represent the voltage inputted, supplied to the room. And this one is regards the reference voltage, the LEDs that represents the temperature and voltage backup system, the displays that will display the temperature, and the virtual terminal that allows the communication between the user and the room, microcontroller, and the same circuit is shown here in the breadboard. The LEDs, temperature sensor, potentiometers. This will cause a serial communication between the user and the system, and the BCD displays are here. The microcontroller is here, and this is the coursework project. Thank you.